So what we will be covering today in this aspect of video is all about the keel, and it's a very important component of ship. When we talk about keel, we'll be covering today the types of keel, what is the significance of keel, what is a duct keel, and what are entry procedures for the duct keel, how we are doing numbering in duct keel, and these were the also questions that were asked, and what is a keel strake. So all these aspects will be covered, and it was upon a request of people that they wanted me to cover the keel, about keel. So without any further ado, we'll begin the thing. So first of all, we look at what is a keel. So if I talk about the Wikipedia, it says that keel is the bottommost longitudinal structure element on a vessel. So you all know this is a common term. On some sailboat, it may have a hydrodynamic and counterbalancing purpose as well, as the laying down of the keel is the initial step of a construction of a ship. So, this keel laying ceremony, why it is important, the reason being is that in British and American shipbuilding tradition, the construction, this is the date when actually which is noted down for a ship when the construction of a vessel starts. So what is the keel laying date? Is the date when the construction of a vessel starts. When we talk about the significance, and as an underwater foil to minimize the lateral motion of the vessel under sail. When we talk about it as a counterweight to the lateral force of the wind on the sail that causes rolling to the sides. So this is the reason why we earlier time we used to had sail on the top. And when we talk about the importance of this is basically all deck officers, they are calculating this UKC, that is under keel clearance. Okay, so because going through a topic doesn't mean that directly you jump on that aspect, because we need to know the significance, we need to have a background of the aspect, and then we can go. Because my idea is to that you need to have a holistic understanding of the topic. When we talk about under keel clearance, then it is the vertical clearance between the deepest point of the ship in the water and the seabed. So wherever is the seabed is there. So the deepest point in the water, in the seabed, and the lower part of the portion of the keel. Okay, it is the important to calculate the under keel clearance of the vessel to avoid grounding of the ship. So why this under keel clearance is important, and to for your knowledge, that whenever the ship is moving in a narrow channel, whenever the under keel clearance is little lesser, so there is a squat effect, and already this squat affects the phenomenon why it is occurring. It is being covered in a separate video, and you can watch that. So that was also a question which was asked. Safe under keel clearance helps the ship to maneuver so that no damage to the hull occurs due to hull impact on the ground. So there is no hull impact. So you must have heard many ships, they are grounding, and many ships they are not coming to the port, they is far away. Because why? This under keel clearance, that is very lesser, the depth of water is. So now how do we calculate this UKC, that is charted depth of water plus height of tide minus the draft. Okay, now when we talk about this charted depth of water, then charted depth of water is the distance from the chart datum to the seabed. Now, chart datum is merely a reference point from which all the depths on the chart are measured. So there is a reference point which is taken, and from this reference point we are considering it to be the point, and from there all the distances are measured and calculated. Charted depth is not the actual depth of water. Actual depth of water will be from the water line to the seabed. So actual depth of water will be from the water line to seabed. It is obvious, na? Because to that degree the water is available in present, not from chart datum to the seabed. Therefore, seafarers need to add the height of the tide. So that is the reason why here you see we are adding the height of the tide. Why? Because this charted depth of water is not the actual height. Okay, Charted depth plus the height of tide will give the total depth of water. So this is the total depth of water. You are subtracting the draft, and when you subtract the draft you get the UKC, that is under keel clearance, minus the draft of the vessel will provide under keel. On the basis of under keel clearance we can decide whether it is safe to go in the area or not. Based on this we decide. Now keel laying I have already discussed. So there were two important things. What was the importance of keel in the ship's operation was the under keel clearance, because this is a very important phenomenon for safety aspect, and they always calculate before going. And the second one was keel laying, which we have already discussed. Laying the keel is the first part in the hull construction, and the day is often marked as a ceremony known as the keel laying ceremony. Keel laying also has importance in IMO convention, and it is the date the construction of the ship start. Okay, it is the date which is counted that the ship construction, because you must have imagined all the SOLAS regulations, MARPOL regulations, they are saying ship constructed after and so and so. So that is the date. That is the reason why the date comes into picture. When we talk about keel strake, then I earlier said that keel is a plate that is backbone of the ship. So it is like we have a vertebral column wherein all the you see the rib cage, all the bones are connected. So keel is the same way, it is the vertebral column of the ship, it is the backbone of the ship. But keel plate is also made up of smaller sections of the steel plates. So but when we talk about the keel plate, those are also made of smaller plates. These strakes of plates that form the keel of the ship is called keel strakes. So understand. So keel of a ship is also plate that is a backbone of the ship, but keel plate is also made up of smaller section of the steel plates, because it cannot be one piece. It is not by casting, it is made by welding different smaller plates. These strakes of plates that form the keel of the ship is called keel strake. So I hope it is clear. This is also very important as per in ship terminologies when they ask you. I have also covered a video wherein I have covered all the ship terminology probables ones which are asked by surveyor, whether it is camber, whether it is rise of floor, dead rise. You can watch that video. The plates in the keel strake are numbered from aft to forward. Now when we talk about numbering of the ship, when we talk about these numbering, then you see whenever there are two types of, actually basically I'll show you the diagram. There are two types of thing. One is the side shell plating, the other one is the bottom shell plating. So when we talk about the bottom shell plating, there comes the keel strake, and when we talk about the side shell plating, there comes the shear strake and garboard strake, which I'm not going to explain it here because I've already covered in previous. You can watch that. So here you see whenever the numbering of side shell plating takes place, then it is always from aft to forward and from down to top. Okay, from the bottom to top. So that is why garboard strake, this is the A strake, suppose this is the A strake, and the topmost one is the shear strake, okay, which is thicker in size. Significance and all I'm not going to tell now. So this A strake is also known as garboard strake. Okay, so see here, the plate in the keel strake are numbered from aft to forward, starting from aft on which has the number 1. So all the garboard strake, which is the A strake, from numbering, so it will be A1, A2, A3 from aft, and it will come till forward till AN. Okay, same way B will go second, then it will be B, B1, B2, B3, B3, and so on, BN. C, D. So numbering is from aft to forward, and the letters, the alphabets, are from bottom to top. Okay, unlike the other strakes, keel strake do not have letter associated with its naming. So keel strake doesn't have its. This was about side shell plating. What I'm talking: A1, A2, A3, B1, B2, B3, B4, C1, C2, C3, 4, C4, and so on. But the side shell plating, when it has only numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and from aft, and it is coming till the forward. So I hope this is also clear for you how the numbering of the ship is being carried out for the side shell plating and for the bottom shell plating. So this is also one of the important thing, wherein you also saw the shear strake and the garboard strake and the keel strake. Now this is important. What are types of keel? When we talk about types of keel, there are three types of keel basically. The first one is the flat plate keel. When we talk about flat plate keel, so flat plate keel is a solid plate which is supported by frames. So they are supported by frames. You see here, this is flat plate keel, and they are supported by the frames running around the vessel. It is thicker than the adjoining plate and must be of full uniform thickness of 3/5 of length of amidship. It may gradually reduce towards the end of the ship and is most common in a majority of ocean-going vessels. Flat plate keel be fitted with the single bottom hull or with the double bottom hull. So with both the type of ship it is fitted. In single bottom hull construction, the flat plate keel plate forms an I section with a vertical longitudinal center line plate on top of it and a horizontal plate above the longitudinal beam. Okay, the vertical longitudinal beam is known as Keelson plate. So this is the vertical longitudinal beam is known as Keelson plate. So this can be asked, what is a Keelson plate? Okay, so we read it here again for you. Flat plate keel may be fitted with single bottom hull or double bottom hull. In single bottom hull construction, the flat keel plate forms an I section. So here we have an I section with a vertical longitudinal center line plate on top of it and horizontal plate above the longitudinal beam. The vertical longitudinal beam is known as Keelson plate and the vertical plate above it is known as rider plate. So the rider plate and the longitudinal plate, sorry, Keelson plate, you are aware of it. Okay, and the vertical plate above is in double bottom construction, flat plate keel forms an strong I section with the vertical plate commonly called the center girder and the horizontal plate part of the tank top. So this is the horizontal tank top part, this is for the double bottom. So here you Keelson plate and the rider plate, that was for the single bottom. So here you say this is inner bottom, you say here, and this is the flat keel. This is the center girder, this is the floor. There's a floor we are talking about. What are different types of floor, that also I have covered. Bar keel. When we talk about bar keel, a steel bar is placed at the center of the keel called the bar keel. So as the name suggests, it consists of a bar which is supported by frames running around the vessel. It was used primitively when shipbuilding changed from wood to steel. So when the shipbuilding changed from wood to steel, the bar keel is made up of a flat steel bar or a steel plate of depth and thickness built to classification society requirement. This is stronger and heavier than the flat keel. Steel plates on either side of the bar keel are known as garboard strake. So garboard strake I already have shown in the diagram. It is found mostly in single bottom hulls supported by solid floors with or without center keels and plate. It is less common on new ships and in more common on smaller vessels like ferries, tugboats, where grounding is more of a risk because it is very strong. It forms a I-beam part. So even it is grounding, so it is not going to damage much. Bar keel does not provide sufficient strength for large ships as there is no direct connection between keel and the floor. Hence flat plate keels have replaced bar keels on large vessels. Now, so this is the thing, this is the bar keel that we were talking about. These are the floor which doesn't form a direct connection. These floors doesn't form a direct connection to the bar plate keel. That is the reason why the strength is not there. Okay, this is the floor. Now these are floors are of different type. There are watertight floors, there are solid floors, there are bracket floors. Okay, so this is the center keelson, that, and the above it will come the, that is the rider plate. So this is the garboard strake that we were talking about. This is the first strake that connects to the keel plate to the side plates. Now duct keel. Now this is important one, the duct keel, and this can form a separate part of a question. So duct keel is provided in double bottom ships, hull ships, and consist of solid plates welded into a box shape. So you can imagine that it is like a box shape, forming an internal watertight passage running along the length of the ship. Internal watertight passage it is, and it is runs along the length of the ship because the keel will run along the length of the ship. There is nothing new in that. Usually from collision bulkhead to forward engine room bulkhead. So if they ask you what is a duct keel, so you have to answer that duct keel is provided in double bottom hull ships and consists of solid plates welded into a box shape, forming an integral watertight passage running along the length of the ship, usually from collision bulkhead to forward engine room bulkhead. It is formed by two longitudinal girders which should not be less than 1.83 meters apart. So this is the requirement. So you can say what are the requirements of duct keel. So this must be watertight, must be in box shape, running from collision bulkhead to the forward of the engine room, and these are two longitudinal girders which cannot be less than 1.83 meters apart. Now the distance must not be exceeded as girders must be supported by keel blocks when docking. Transverse stiffening bar or brackets are normally provided on the keel and inner bottom plating between the girders. So transverse, so this is the diagram all together. Okay, transverse stiffening bar or brackets are normally provided on the keel and inner bottom plating between the girders. Now we talk about the advantages of duct heel. They are higher strength compared to other types of keel as they give excellent resistance to load due to its box structure. So as compared to bar keel, compared to flat plate keel, they have better excellent resistance to load. Okay, it allows protected cables. Now because since it acts as a box, it's it allows protected cables, bunkers, pipelines and ballast pipeline to run fore and aft beneath the cargo spaces. So it will act as this. This allows the pipeline to be easily inspected even when cargo is loaded. So even when the cargo is loaded, because in other type of keel what happens, the pipeline has to run from the tanks. So inspection of a cargo pipeline becomes very difficult job. We are going to see that. But when it is running in a duct keel, then it can be inspected very easily when we are inspecting, because we can make an entry even when the tank is fully loaded. It is possible to carry oil and water pipes in the duct to prevent contamination which could occur if the pipe passed through cargo tanks. Okay, so it is possible to carry oil and water pipes in the duct. Okay, it acts like coffer dam because coffer dam is a very empty space. So I've already covered whatever void space, what is a coffer dam. Coffer dam and is provided with a sounding pipe to detect any leakage. So since any space which is devoid of human entry, it is provided with a sounding pipe on the ship, and regularly the sounding is taken because it is directly exposed to the sea, so there can be a leakage and there can be a flooding and ingress of water. It is very important to carry out duct keel inspection on a regular basis. So we need to carry the inspection on regular basis. Duct keel have bunker and ballast pipeline running along its length, full length, and connecting to various bunker storage tanks and ballast tanks. Any leakage from these pipeline can cause severe problems and risk the safety of the ship. Hence, it is necessary to carry out periodic inspection of the duct keel. Okay, because to detect the leakage, we need to carry out the inspection. So you can see this box type shape, and there are pipelines which is running. It's like a coffer dam. Space altogether provided. There are electrical connections which are also running. So these are different flanges that there, bunker pipeline or water pipeline, they are also uh, running there. Now when we talk about precautions, so this was a separate altogether thing, that what are the precautions before entering by duct keel, it was asked. Now open the inlet and outlet ventilation flap of the duct keel. The flap will be present on the deck near to the collision bulkhead at the start of the tunnel and near to the engine room forward bulkhead at the end of the tunnel. Now when we open it, we start the duct keel fan. The only thing is that we are opening is the inlet and outlet ventilation flaps. These terms you need to remember. Otherwise, the entry procedure for an enclosed space, because it will be treated as a enclosed space, that will always remain same. We need to carry out the risk assessment. We need to have checklist. Start the duct keel fan. It may be one in number or two depending on the size and volume of duct keel. The fan can be switched on from ship's control center or from the bridge. So now these fans are remotely operated or locally operated. Both the medium is possible. Switch on lights for pipe duct. So we switch on the lights for the pipe duct. This can be done from the bridge or from ship's control center. Enough illumination should be present before entry. So what are we are doing? We are opening the ventilation flaps both side. One is present near to the collision bulkhead and near to the engine room forward bulkhead at the end of the tunnel. Then we are starting the duct keel fan. Then we are switching on the light. Per illumination must be present. Open the entry hatch cover of pipe duct keel. Let it be open and allow it to ventilate for minimum 15 minutes for proper circulation of fresh air inside. So we open the entry hatch cover. So there is a entry because we cannot be entering from this flap. So there is an entry flap is there, cover is there, entry hatch cover. So we need to open that, and because that will also be, that is also closed for long time. So what we are doing, we are keeping it open for 15 minutes for proper circulation of fresh air inside. Prior entry to duct keel, duty officer has to be informed. One person has to be present standby at the entry of the duct keel to communicate with the person inside. So one person has to be standby. All these procedures are similar to what we are discussing in enclosed space entry. Okay. Now inspection. What are the inspection to be carried out in the duct keel? One of the main problem of the pipe duct keel leakage is from the flexible coupling. So see, there are flexible coupling that are being provided inside the bunker pipeline, in between bunker pipeline. We have expansion joints or flexible coupling whose purpose is to resist the ship's flexing, because the ship will flex because there are two types of stresses that falls, that is hagging and sagging and hogging. Okay, so to avoid that, to resist that, there is a tolerance that is given. Okay, its purpose is to resist ships flexing. So this flexing is nothing but hogging and sagging. When ship is under heavy sea load during rolling and pitching, the flexible couple loose and results into leakage of fuel in the duct keel. So this flexible couple will raise because sometime one part will compress and sometimes the one part will contract. Contraction and expansion will take place. So because of this reason, there can be there are chances that leakage will be there. It is important to check every flexible coupling visually during inspection. So the first thing what we are checking is the flexible coupling of the bunker pipeline. Visually inspect the condition of lagging over bunker pipeline, because there are lagging because there are heat tracing lines where insulations are provided to keep the bunker warm. These heat tracing lines can be steam lines or electric heat tracing lines. Check the working of bilge alarm. There are bilge alarm because obviously there must be bilge because it is in closed space. If there are ingress, so we need to check the bilge alarm. So there are level switch float, so we can lift that and then alarm will sound. Visually check the condition of bunker remote valve. There are bunker remote valves which we have to visually check. These valves are very critical important as they use to transfer bunker from storage tank to the settling tank. So those lines are also passing from here. They are operated remotely and can be operated manually in case of remote operation failure. After inspection of the bilge, make sure the bilge alarm floats are back to normal position, not stuck. It must not be stuck because that will create a problem and error. After coming out of the duct, we'll switch off the fan, as continuous running fan may risk of burning the motor. Whatever we done, we will set it to back. Close the inlet and outlet flaps of the ventilator. Important. This is often forgotten during rains and seep inside the motor and decreases its insulation resistance and often results into burning of the motor. So once a month it must be carried out. As the duct keel is long, many ships have track and trolley arrangement to move along the duct keel. So they have track and trolley arrangement because it is from collision bulkhead to the engine room. So you can imagine almost the whole length of the ship. The trolley also aids to carry heavy things in the confined space. Make sure you lock the movement of the trolley with the help of a simple pin lock arrangement provided after use, or else it will keep moving freely when the ship is pitching and get damaged. There are also lights throughout the duct keel, and not less than 50% of them should be emergencies from emergency switchboard. So these lights are provided from the emergency switchboard, and 50% of lighting has to. So these are requirement of the Solus, you can say. Duct keel has two accesses, one from the forward of the engine room and another from the collision bulkhead. So there are two accesses. The access hatch should always be closed when at sea. So access has not to be open. So if there is a flooding, if there is a suppose there is a flooding that occurs, then how we are supposed to tackle these flooding if in the duct keel? It is a confined space. A sounding pipe is usually provided, as we have discussed. Dry at all the time, and it carries several pipelines from various purpose: ballast, fuel, steam, etc. A leakage in any of the pipeline to duct keel may have caused a serious stability issue if not corrected. So these have been cases of ship being capsized due to the flooding of the duct keel. Following steps to be taken in case of duct keel flooding. So if there is a flooding, so these are the steps that are supposed to be taken. Never block duct keel alarm. In case of major flooding, sound the general emergency alarm, invite manpower, inform master, chief. Please keep checking the sounding of duct keel frequently and measure the rate of increase in the level to access the leak. Keep a track on earth fault alarms and do not take them lightly, as electrical wiring also pass through duct keel. If the leakage rate is manageable, a portable pump can be used to pump out bilges from the duct keel to sludge or bilge tank depending upon the content of the keel. Because if there is oil contamination, you cannot directly ballast it overboard. To check the area of the leakage, ensure the bilge level inside the duct keel is kept minimum by continuous pumping. A reasonable ship officer must go inside the duct keel and check the location of the leakage. Ensure to ventilate the duct keel by supplying fresh air throughout provided fans. An oil leakage in the duct keel may cause hydrocarbon vapor to accumulate inside the duct keel. Ensure to take similar precautions of entering an enclosed space and keeping rescue equipment and breathing apparatus ready before entry. Use the trolley to travel the keel and locate the leak. If the bilge inside the keel is a higher level and human entry is ambiguous, the ship can be ballasted to increase after trim. The officer can then enter from the forward and mid depending upon the accessibility and bilge level. Once the leakage is located, try to repair it at the earliest or isolate the point of leakage. If the line vent tank cannot be isolated, empty the tank content from which the leakage is happening. If the tank from which the leakage is connected cannot be emptied or isolated, the ship should continuously monitor the duct keel sounding. These are self-explanatory, that's why I'm just reading, going through. It is always advisable to keep all the excess manholes shut and tight as well. Leakage may turn to more prominent leakage, leading to ingress of water in the engine or pump room in no time. Provision of a bilge suction pipe shall be made to prevent the flooding of duct keel in the event of piping being severed or otherwise damaged through collision or grounding. In case of duct keel flooding, after getting the approval of master and chief engineer, open the bilge suction valve to tackle the emergency. So with this we come to an end of this video, and today we very finely and minutely were discussing about we discussed about certain things, and what is a keel and what are the importance and significance of keel. There were what is UKC, under keel clearance, what is the significance of under keel clearance, and then we discussed about what are the types of different types of keel, and before that we also saw what is side shell plating, bottom shell plating, and how the numbering is done, what is a keel strake, and then we saw the types of keel, what is the bar keel, where it is being used, what are Keelson plate, what are rider plates, and then we saw about flat plate keel, and then we saw what is a duct keel, And then we saw the advantages of duct keel with the diagram, and then we saw what are the entry procedures for a duct keel, what are SOLAS requirement for duct keel, the distance between two girders, that is 1.83, and all those things. Then we saw what if there is a flooding in the duct keel compartment, and then we come to a conclusion, if there is a man entry, after entering what all things has to be restored back. Okay, thank you so much.